Okay, gang, welcome to 3.7, optimization. So, optimization problems are kind of like related rates in that there are formulas. There are a bunch of different types of these. Hopefully we'll practice enough to get better at them. So, for optimization problems, you have to take the wording of the problem, find what formula. A lot of times they don't give you that formula, sometimes they do. So this one says, what's the smallest perimeter? Optimization is always, you'll know it's an optimization problem, you always want the largest or smallest something, okay? In this case, the largest or smallest perimeter, okay? Possible for a rectangle whose area is 16 inches squared, and what are its dimensions, okay? So, when we do this, okay, a lot of times they'll have multiple formulas going on. You have to know which one you're maximizing, which one you're minimizing, and the other one you're going to use to plug in. If you remember the cone problem, you're missing a piece of information, well, that's what we're going to do here. So again, for perimeter, we have perimeter equals 2 times the length plus 2 times the width, and area is length times width, all right? So, when you do this problem, there's going to be a lot of weird exponents and solving weird things. That's what makes these harder, not that difficult, but again, you want to figure out the numbers. You'll have to do some sign analysis, kind of application of the first derivative test, things like that. So over here, I'm going to solve for length in terms of W. So you're going to get L equals 16 divided by W. So that's going to help us. And again, you could have solved for W in terms of L. It wouldn't matter either way. Sometimes it's easier one way or the other. It all depends on the problem. Okay, so what we're going to do now is we have too many letters here, so we want to get rid of them. Okay, so I'm going to plug in for L. So it's going to be 2 times 16 over W plus 2 times W. So that's going to be 32. P equals 32 over W plus 2W. And again, I like to rewrite that as P equals 32 W to negative 1 plus 2W. Now we're going to take P prime again in this section, take the derivative. Okay, so that's what we're going to do. All right, so you're going to get 32, negative 32, W negative 2 plus 2. All right, so there's your P prime. So now what we're going to do is we are going to set that equal to 0 and solve. Okay, set that equal to 0 and solve. All right, so we're going to go ahead and do negative 32 over W squared plus 2 equals 0. Negative 32 over W squared equals negative 2. Multiply both sides by W squared. Okay, so you'll get negative 32W squared equals negative 2, negative 32, 2W squared, negative 2. Divide both sides by negative 2. You're going to get 16 equals W squared. So W equals plus or minus 4. But since we're talking about length and width, then you know that the length or the width is positive 4 because you can't have negative lengths, okay? You can't have negative lengths. All right, so when doing that, again, this is only one answer. There'll be times when you get more than one answer. So once you get one answer, what you want to do is do your sign analysis, okay? So plugging in 4. Again, you want to make sure that this is a local min because you want the smallest. So if there's multiple numbers that you get, how do you know which one is the min, which one's the max? You'll do your sign analysis just like we did before. So again, we want to do sign analysis on the derivative. So we're going to plug it in here. Okay, we're going to plug it in here. So plug in, can't plug in 0 this time. So you can plug in like negative 3. See what you get there. And the answer should be negative, positive. All right, so that tells me we have that type. So that is a local min, okay? So we're good to go. So it says, what is the smallest perimeter possible for rectangle's area is 16 inches squared? and what are its dimensions. Okay, so find the length. The length is 16 divided by W, so we have length is 4, width is 4. That takes care of the dimensions. To do the perimeter now, all you do is plug it in here. So it'll be 2 times 4 is 8, plus 2 times 4 is 8. 8 plus 8 is 16. So perimeter is 16. So there is your smallest perimeter possible for a rectangle who is 16 inches square. That's actually a square, but again, square is a rectangle. All right, now, cylindrical can of volume 10 feet cubed so that it uses the least amount of metal. Again, we're going to be looking for a min, all right, a min. So when you do this, a cylinder kind of looks like this. Again, forgive the drawing, okay? So we know volume is equal to pi r squared h. Again, that'll be given to you probably in the problem on the final. All right, so we need to solve volume in terms of things, but before we do, let's see what we have here, okay? So, to use the least amount of metal, that's the surface area of a cylinder, least amount of metal. So, if I was taking this, and say I cut the tops off, and I flatten this part out, you would end up with that, and you have, there's the middle part. So I cut the top and bottom off, and I took this rounded part of the can and I flattened it out, you'd end up with that. Okay? So, this is 2 pi r for its area. 2 pi r, and again we're talking about the least amount of metal, which is surface area. And then this would be, this length would be, it'd have to go around this, which is 2 pi r. Again, I'm getting that, that's the circumference of the circle, okay? So this is 2 pi r. Again, it would have to wrap around there, and this is h, the height, whatever the height is of the can. So again, the can circumference is 2 pi r. This part circumference is 2 pi r, which makes this distance around here, which would be that metal piece, 2 pi r, and that would be its height. Okay, so surface area now, surface area is equal to 2 pi r squared. Okay, and again, why is it 2 pi? Oh, I'm sorry. I wrote the wrong number here. Sorry. I wrote 2 pi r. This is pi r squared, pi r squared. That's the area of a circle. There's 2 of them, so 2 pi r squared. The circumference is 2 pi r, which is the length, and again, area of a rectangle would be what? 2 pi r times h, okay? So now we have too many variables again. Like up here, we had length and width. Here we have r and h, so we got to get rid of one of them, all right? So what we're going to do is we're going to solve for h in terms of r using this formula. We know the volume is 10, so that's going to be 10 over pi r squared equals h. 10 over pi r squared equals h, okay? So we're going to go ahead and plug that in here, all right? So you're going to get area equals 2 pi r squared, because there's 2 pi r squareds, plus length times height, but we know height is now that, so you're going to get 2 pi r times 10 over pi r squared. Now, my recommendation is to simplify before you take the derivative, otherwise you might, make it difficult. So what's going to happen is the pi's cancel, that r cancels with that, so you're going to get 20 over r, okay? So again, the least amount of metal is the surface area. This area is pi r squared, this area is pi r squared. The length that this would cover around would be 2 pi r, because that's the circumference. Height would be h. We solve for h given that. That's usually what happens in these when you're given this formula. Now take the derivative. So we get a prime is equal to 4 pi r minus 20 r to the negative 2 power. Again, that's 20 over r is 20 over r to the negative 1 power. Again, take the derivative, set it equal to 0. So we're going to go ahead and do that over here. So we're going to get 0 equals 4 pi r minus 20r squared. Now again, solving this is a little difficult, but should be able to do it. So you're going to get 20 over r squared equals 4 pi r. Okay. Again, here's, you want to multiply both sides by r squared. So you'll get 20 equals 4 pi r cubed. Okay, so 20 equals 4 pi r cubed. So now we're solving for r. So you're going to get 20 over 4 pi equals r cubed. Take the cube root of both sides. So you're going to get r equals 20 over 4, which is 5. I'm just going to write 5. Okay, so it's just going to be, this is going to be 5. So 5 over pi, cube root of that is r. Okay, so then it says it wants to design a cylindrical can. So we know what r is, we just have to find h. So we have to find h. So we know h is 10 over pi r squared. So this is, again, algebra nightmare, but we got to do it. So we have h equals 10 over pi times the cube root of 5 over pi squared. Now again, I would just leave it as that. There's no reason to simplify it. Again, if this was on the final, it would be multiple choice, so you could figure it out from there, but I don't think this would be one on the final, too difficult. All right, now, the last example is the most difficult, because once you start getting ones where y and x are like this, and it's not y equals given to me, you're going to have to solve for y, and then solve it. And then you'll get to a point where it's an algebra nightmare, and you can't go any further, so then switch it and solve for x. So in this problem, I'm going to do it and get to a point that is unsolvable. Then I'm going to try a different method. So find the point P on the parabola y squared equals 2x closest to the point 1, 4. Okay, so first of all, you need to know this formula. And again, those that had me before know that this is the formula for distance. Again, how do I know? Because we're talking about closest, so we're talking about distance. So, if I solve for y here, and I leave it as y equals, you're going to get y equals the square root of 2x. Okay? Then, when I do my distance formula, I'm going to go ahead and plug in my x's. Now, here's the thing. It says find the point P. So we're going to let P equal, x2, y2, okay? So P is going to be x2, y2, so we're going to go, we'll just call it x. You can write x2, but it's easier for the math to not do that. So we don't know that part, but we do know the other part is 1 squared plus, again, we know y2, well, y2 is equal to square root of 2x, okay? So, again, we know y is square root of 2x minus 4. Again, we're not going to put y2 there, because we don't know it, but we know y is equal to square root of 2x, so we'll put that there so we have all the same variable. All right, and that's squared, okay? So now, taking the square root of that, okay, if I square both sides, you're going to get d squared equals x minus 1 squared plus square root of 2x minus 4 squared. Now, you're going to say, well, why did you take why did you square both sides? It's the only way to do this problem. And you're going to get d squared. And that's okay, because when you do the problem, you're going to take the derivative of d squared, which is 2d prime. So it's not going to make much of a difference in the problem, okay? So you don't have to worry about that. What we're worried about is this side. So then you have to FOIL all this, okay? And or take the derivative and set it equal to 0. Well, watch. If we take the derivative, I don't like foiling, so derivative of that is going to be 1 times 2 times x minus 1, okay, plus this derivative is going to be square root of 2 x, so derivative of that is, again, I'll do it over here, 2x to the 1/2, so it's going to be 1/2 times 2x to the negative 1/2, okay, that's derivative of that. Then we're going to move outside, times 2 times square root of 2x minus 4, the first power. Now here, you have to set that equal to 0 and solve. That's pretty ugly. So probably was a bad idea solving y in terms of x. All right. So I'm going to solve x in terms of y. So I'm going to take this problem and solve x in terms of y, and you get y squared over 2. I'm going to try that problem instead. So now, I don't feel like solving. That'd be very difficult to solve. A lot of x's, don't know how I'm going to get them together, a lot of 1/2s. Watch this. You know you did something wrong when that happens. So here, okay, so now when we have x, we're going to plug in y squared over 2, all right, minus, again, we're still using the 0.14, so minus 1 squared, plus y, now I can use y, because we're in the y realm, right? We don't know x, so 4 squared. So square both sides, you're going to get d squared equals y squared over 2 minus 1 squared plus y minus 4 squared. Now, this is much easier to take the derivative. Again, we wrote y squared over 2, much easier to write 1/2 y squared. Okay, so now we're going to take the derivative, and it's going to be equal to y, okay? Derivative will be equal to y, okay? All right. And then now move out to the outside, you're going to get a 2. Rewrite the inside, 1/2 y, okay? Squared minus 1 for the first power, plus, again, here, we're going to get derivative of the inside is 1, and you're going to get 2 times y minus 4. Much easier to simplify. Notice we don't have square roots, we don't have negative powers, much easier to simplify here. So, when simplifying, okay, you're going to distribute this 2y in here, so you're going to get the 2 and the 1/2 would cancel, so you're just going to get y cubed minus y cubed minus 2y. Okay? So, plus, and then down here, that's just going to be 2y minus 8. That's a 4. Okay? That can be factored by setting that equal to 0. So you get y cubed minus 8. 8 equals y cubed. So y equals 2. So again, you get y is 2. If you want to find x, plug in x. Again, y is 2 is 4. 4 divided by 2 is 2. So x is 2. So the point closest is 2, 2. Again, notice the purple, much easier than this black here. This would be very difficult to solve. So typically you don't want this square root. Okay, you want it to be a non-square, but sometimes the square root is easier. You have to try and see. You'll see when we do some of these problems.